Okay, this lesson we're going to go to the NASA website, foilsim software, and design our airfoils. So the first thing we need to do is find the foilsim site, and you can just go to Google and type in foilsim, and we're looking for foilsim 3 student version 1.5. We may have some issues with Java getting this to load, but we'll take care of that. Okay, once we're in the foilsim site, we want to set up the size and flight conditions for our airfoil so that we can evaluate our shape. So the first thing I want to do is go to the size button here, and we're going to set up the size as we're going to make it. So these are in feet, and the chord again is the distance from the leading edge of the wing to the back of the wing, and that's going to be 3 inches, which is 1/4 of a foot. So you're going to type in 0.25. The span is going to be 1 foot, which is 12 inches. And if you hit the enter key after you type that in, you'll notice that it will recalculate the square footage. So if yours shows up with a 0.25 for the chord, 1 in the span, and an area of 0.25 square feet, we're good to go. That takes care of the size of our wing. Next, we're going to go to input to go to flight, and this is going to change the characteristics of our flight conditions. So we're going to try to estimate what our wind tunnel might be running at, and we're estimating that at 30 miles per hour. We're going to leave the altitude at sea level, and we're going to leave the temperature at 58 degrees and so forth. So it's a little warmer than 58 in the shop, but we can leave it as is. So really we're just changing the speed, and make sure you hit an enter in so that it recalculates. If you don't hit the enter key, nothing happens. So that's going to change this here. So size and flight conditions are good. The next piece is to just go to the shape, and this is where we get to experiment a little bit with the airfoil to see which shape is going to be more efficient, and it's going to graph our results over here so that we can pick one that works well. So one fixed condition is the angle of attack, and we set it to 10 degrees. Again, you want to put enter. You'll notice that the airfoil is now tilted up a little bit in the front. This just zooms our view of our airfoil, and I'm going to zoom it up so that the airfoil just about fits in that stream. We don't. If you hit the streamlines versus moving, either way, I think we can leave it not animated. And then we're going to play around with the camber. Now, before I even change any of these, I'm going to hit the rescale button and just take a quick peek at this information over here. And what this is telling me is the green line is where atmospheric pressure is. All right, that's 14.6 roughly. The yellow line tells me what the air pressure is below the wing. Notice that it's higher than the air pressure, which is shown in this kind of magenta line, which is the upper part of the wing, which makes sense. If the air pressure is lower on top and higher on the bottom of the wing, then we get lift. Essentially, we're pushing the airplane up or sucking it up, depending on how you want to look at the conditions. The pressure ends up being greater below than above. If we change our camber angle, you can see that that changes this graph and increases the pressure below and reduces the pressure up, and we generate more lift. That's shown here. So currently our lift is 1.8 pounds, and there's also something called lift to drag ratio. If we increase the thickness of our airfoil, we increase our lift, but we're also increasing that drag. So your goal is to try to find a good shape where you get a nice amount of lift. You're trying to maximize that lift, and you're trying to keep the drag relatively low. So when you find a shape that you like, what we're going to do is take a screenshot of this screen and bring it into the PowerPoint that we created earlier, and make sure that you have something to analyze and talk about with regard to the flight characteristics of your airfoil. So at this point, I'm just going to do a screenshot, which the easiest way for me to do this, you can't see this, but I'm going to hold the Control Alt button down and the print screen button. And what has happened is I've just grabbed this screen. I'm now going to pull my PowerPoint open and go to the slide 6, 7, and 8. And I'm going to go to slide 6, and I'm going to simply right click and hit paste, and you'll notice that my screen has shown up here. Now I don't want to see all of my Internet Explorer and everything else, so I'm going to start by holding the Shift key and scaling this down, and then I'm going to right click and get the cropping tool and just crop in so that I have my flight data here. And once I'm done with that, I can resize it again to be a little bit more legible on my slide. So this is what we need to do from the foilsim site, the NASA site. You're going to do 3 of these. You're going to experiment with 3 different designs. So this is the first of my designs, and this shows the results of that design. And we want to make sure that we again, we're trying to maximize our lift and reduce the drag so that we have a good lift to drag ratio. I would say that this is probably a little heavy on the drag side, but got quite a bit of lift. I don't know if you've ever flown in an airplane and looked out the window, but at landing time you'll see the wing flaps come out and come down, which creates this large amount of camber, and that allows the airplane to have plenty of lift while it's traveling slower and coming in for a landing. Alright, so we're going to go back to the site, and you're just going to experiment with this until you're happy. Oops, we don't want to change the drag angle, the attack angle. That's going to stay at 10 the whole time. What you're going to do is experiment with this. Ultimately, when you get your best design, when you find one that has a good lift to drag ratio and a shape that you think you want to build, we're going to copy that one into PowerPoint, but then we're going to save this image as well, and I'm going to show you how to do that. I warn you that you can't, we don't have good luck when you start making these paper thin wings. The shopbot will just tear it all up, and you won't be able to construct it. So while you may have a good lift to drag ratio and your flight characteristics might be ideal, the fabrication of something that thin is not going to work. So you want to keep you want to keep enough thickness, and I would say somewhere in the neighborhood of 8% on the cord thickness is probably getting to as low as you'd want to go. So let's say that that was the wing. I didn't look at my numbers carefully, but let's just say that that's the wing that I wanted to go with. Again, I'm going to hit Control Alt and print screen on my keyboard. I'm going to go back into PowerPoint and go to my next slide, and I'm going to paste that in and resize it. Whoops. Hold the Shift key down and right click, get the cropping tool up. Again, we just want the data here, and once we have that, we can resize this again. I like to hold the Shift key so things stay in proportion. Now once we have this, from within PowerPoint, I want to save a copy of the design that I like. So I'm going to right click and I'm going to go to Save Picture As. I'm going to go back to that folder that we created for this project. Let me find our folder. So my IT folder, my Airfoil project, and I want to save this as a JPEG, and I'm going to call it last name, first initial, Airfoil. Oops. And this is going to be a picture that I'm going to bring into SolidWorks, which is going to be the next lesson. So you hit save. So we've got a couple of our designs. You're going to do 3. Your favorite one, you're going to save that image to the folder, and then we're going to use it in SolidWorks. That wraps up this.